Welcome. In this session, we are going to differentiate yet another logarithmic expression. This has been chosen specifically to illustrate one important point about differentiating logarithmic expressions, especially when you need to simplify that. The problem is to differentiate ln of cube root of some fraction. If I follow my standard procedure, I would just start on the outside, apply the appropriate rule, and go from there. So if I do that, first I have ln. Derivative of ln u is 1 over u times derivative of u. So we start by taking the reciprocal of what's inside ln. Instead of writing it as a reciprocal, to make it easier to read, I will write it as what's inside ln to the power -1. Inside I have cube root. Cube root is power 1/3. So I have to use the power rule. I get 1/3 times whatever is inside the cube root to the power 1/3 minus 1, which is -2/3. Inside the cube root I have a fraction. To differentiate a fraction I use the quotient rule. The numerator of the fraction is x squared plus 1 power 4. Its derivative, well, it has an exponent 4, so I differentiate for that exponent first. So I get 4 times x squared plus 1, the quantity inside the parenthesis, to the power 3, multiplied by derivative of the inside. Inside is x squared plus 1, its derivative is 2x, times the denominator of that fraction, which is x power 4 plus 1 quantity squared, and then minus the numerator, x squared plus 1 power 4, times derivative of x power 4 plus 1 quantity squared. There is an exponent on the outside, so I use the power rule. 2 times the quantity inside the parenthesis to the power 1, times derivative of the inside. The inside is x power 4 plus 1, its derivative is 4x cubed. The whole thing over the square of the original denominator, square of the quantity x power 4 plus 1 quantity squared. This is fine if we don't care about simplifying the expression, but if we need to simplify it, this is going to involve quite a bit of algebra. But I could have used properties of logarithms to rewrite the original expression. Remember that logarithms convert multiplication to addition, division to subtraction, and exponents inside logarithms become coefficients outside. So if I start with this expression, I have ln of cube root of something. Cube root is power 1/3. So that's same as 1/3 ln of the quantity inside the cube root. Inside the cube root I have a fraction, so I can split it up. Ln of a fraction is ln of the numerator minus ln of the denominator. Of course I have the 1/3 out front, which needs to be distributed over the 2. Now each of the two terms inside the braces is ln of power of some quantity. Once again I can bring the exponents inside the ln, outside as coefficients. So ln of the quantity x squared plus 1 power 4 is 4 times ln of the quantity x squared plus 1, and ln of the quantity x power 4 plus 1 squared is 2 ln of x power 4 plus 1. Now if I distribute the 3, I get 4/3 ln x squared plus 1 minus 2/3 ln x power 4 plus 1. Now I can differentiate this, which is a lot easier than differentiating the original expression. In each of the two terms, I have a constant factor times ln. Constant factors stay as they are when I differentiate. To differentiate a logarithm, I take the reciprocal of the inside. So to differentiate ln of x squared plus 1, first I take the reciprocal of x squared plus 1, which gives me x squared plus 1 in the denominator. Multiply the derivative of the inside. The inside is x squared plus 1, its derivative is 2x. Same way in the second term I get 2/3 and then x power 4 plus 1 in the denominator, 4x cubed, derivative of x power 4 plus 1 in the numerator. Can do a little bit of simplification, so I get 8x over 3 times x squared plus 1 minus 8x cubed over 3 times x power 4 plus 1. If you need to simplify, you would just put this over a common denominator. But in any case, the algebra involved in simplifying this answer is much shorter and easier than the algebra involved in simplifying this answer. This observation is the basis of what's called logarithmic differentiation, which we'll study in section 5. I will end this session here.